For the OGC Testbed 15's Open Portrayal framework, Ecere improved the visual style editor of its GNOSIS Cartographer GIS tool. During Testbed 15, we rewrote both the GNOSIS rendering engine and GNOSIS Cartographer's visual style editor to render maps and edit styles based on CMSS. The style editor allows to dynamically change the symbology with instant visual feedback. For example, here we are adjusting the color and opacity for filling polygons and the stroke color and width. Interoperable styling poses difficult challenges because the definition of styles is often tightly coupled with the rendering engine and its capabilities. In the previous Testbed 14, the concept of a common conceptual model with the possibility of multiple encodings was put forward. During that initiative, we had proposed what became the GNOSIS Cascading Map Style Sheets, or CMSS for short, as an encoding for such a conceptual model. Here we are changing font, color, and outline settings, as well as which attribute to use to label roads. The editor's Rules panel concisely presents all defined styling rules and selectors associated with each of them. We can apply two separate colors to monochrome icons for symbolizing points of interest. In the Selector Editor, a list of all available values from which to choose is available. It is also possible to manually define or edit complex logical expressions. In addition to selecting symbology based on data attributes, the scale at which the data is being visualized can be considered in choosing the symbology. This scale selection also applies to 3D views, where features further away will be considered as having a larger scale denominator. Symbology for raster data, such as coverages defining digital elevation models, can also be edited. Here we are demonstrating customizing the color map to apply to such an elevation model. Specific colors and values at which they should be applied can be chosen. Predefined color maps can be saved and selected. It is also possible to control the hill shading properties, such as an intensity factor, the elevation and azimuth of the sun, as well as specifying a custom shading map. Styles can also be applied to imagery data, for example, changing its opacity. These styling capabilities are available and work the exact same way regardless of how the styles are encoded and whether accessing data tiles and styles from an OGC API or from an offline geopackage or GNOSIS data store, thus providing a consistent online-offline open portrayal framework.